Good day, my friends. Let's learn something new today. Okay, let's dive into the world of numbers. Wow, that's quite nice. Right, let's dive into the world of numbers. Welcome to this exploration of a fascinating world of numbers, where we'll delve into rational and irrational numbers, their real-life applications and operations that govern them. And I think that our objective over here of this lesson is going to be how to use rational and irrational numbers, what they are, where to use them, where we will find them, and how to use them. And of course, don't forget, it is by myself, Alfred Grobler, writer, and there you can see a photo of me as well. Good, we're doing so well. Right, guys, let's go and have a look at the basics of rational numbers. Firstly, what are they? What are rational numbers? Now, rational numbers can be expressed as a fraction, where the numerator and denominator are integers. So in other words, if the denominator is a whole number, you get in a fraction, it is a rational number. Alright, examples, let's look at some examples. For instance, 3 over 4 minus 2, 0.75, because 0.75 is a 3/4, 0.333333 because it's a repeating pattern, is 1/3, 5, they are all rational numbers. Numbers like that, etc., is all rational numbers. Also, if you look at the other videos that I've made on rational numbers, you can see exactly, or hear exactly, what are rational numbers and how to determine which is irrational and which is rational. Okie dokie. Let's have a look at some places where rational numbers are used in everyday life. Right, let's have a look. Oh yeah, you can see as it's a recipe, where they'll be cooking something or whatever the case might be. That's one place, of course, in the kitchen. Right, let's go and have a look. As I said, cooking. Right, and now in cooking, recipes often use fractions for ingredients, like half a cup of flour or a 3/4 spoon of salt. Yes. This usage in cooking, you'll see it regularly, continuously. Right, next one, let's have a look at the next one. What is it? Oh, and money, yes, of course, right? Because money is a rational number, as it can be expressed as a fraction of a dollar. The cent is actually a fraction of a dollar. 25 cents is a quarter of a dollar. 50 cents is half a dollar, etc. Yeah, that's quite good. And let's have a look at the next one. In measurements, of course, yes, right? Measurements like 3.5 meters or whatever, that's talking about feet over here, or like 2.5 meters, use rational numbers, right? Feet and yards and stuff like that, that is the old English system. I think the Americans are still using it, although the rest of the world, we're all using meters and millimeters and centimeters, etc. Right, and let's go and have a look at another one. Time, yes, of course. Right, 30 minutes, half an hour. Right, there you can say fractions have half an hour of a day, or an hour, or whatever the case might be, half a day. These are places where you'll be using rational numbers and fractions virtually on a daily basis, guys. Okay, let's have a look at irrational numbers. What are they, and the key characteristics of irrational numbers. Irrational numbers cannot be written as a simple fraction. Their decimal representations go on forever without repeating. Well, that's a whole lot said. Examples of that is, for instance, pi. You use this continuously when you're working with circles, etc. The square root of 2, there's no end to it. Euler numbers, right? This you'll come across many times in when you're programming games, etc., like this. Euler angles, etc. You come across it quite a lot. Are all irrational numbers. Yeah, guys, you'll come across it, and as I said, if you watch the previous videos on the podcast on irrational numbers and rational numbers, you'll see exactly how to determine the difference between the two. Okay, let's have a look at why irrational numbers matter. Why are they important and why do they matter? Right down at the bottom of the pyramid, the first one that we've got, of course, is it gives you a much broader understanding of how the whole number system works. So understanding irrational numbers enhances your comprehension of the number system as a whole. As I said to you, it'll give you a much better understanding of how the number system works. Right, let's go look at the second part of the pyramid. Where is it? Oh, there it comes now. Righto, guys, and let's go and have a look what it is. Real world significance. Wow. Irrational numbers are essential in various fields like physics, engineering, and computer sciences. Yes, guys, in engineering and etc. like that, I'm telling you this. Irrational numbers really do matter and it makes a very big difference, believe it. And right at the top of the pyramid, what do we have? Righto, let's have a look. Oh, completeness. It completes the whole number system. Huh? Irrational fills in the gaps between rational numbers, making the real number system complete. Well, that's a whole lot said, but yes, like I said to you before, if you watch the podcast and the explainer videos I made on rational and irrational numbers, you'll understand this here much better. Guys, I really advise you to maybe have a look at those videos too. Let's go and have a look at the the operations of rational numbers. The first one, of course, being addition, right? First thing that we're going to be looking at, of course, and that is to find a common denominator. Guys, that is most probably the most important factor over here. For example, a half plus a quarter, your common denominator will be 4. And you always want the lowest common denominator between the two fractions, right? The second thing, you add the numerators together. Once you've got a common denominator, you can just add the numerators together. In this specific case over here, you've got 2/4, right? If you work it out, and 1/4, and it'll give you a 3/4. The third one, of course, simplify the result. Guys, that is so important, right? Like a 3/4 can't be simplified any further. It's in its simplest form. But always make a fraction into its simplest form. Now, we'll be going over the giving you examples of all 4 of the operations. Yeah, I've just mentioned the addition. A denominator, I think, is only applicable to addition and subtraction. Multiplication and division works a little bit differently. Righto, with that said, let's move on. Okay, let's go and have a look at the operations with rational numbers, namely addition, subtraction, multiplication, and division. Addition, the first one. You add the numerators after finding a common denominator. This is very important when you're doing addition, guys. And you also remember you want the lowest common denominator between the two, or between the fractions, right? That's very important. Multiplication is a little bit different. You multiply the numbers and the denominators, like the numerators and the denominators. That's very straightforward and quite simple. Subtraction is once again the same as addition. You need to find a common denominator, and of course again it will be the lowest denominator. Then you can just subtract the numbers from each other. Very simple. And of course with division, it is a little bit different. You're just going to take the last fraction. If you're multiplying 2 fractions, you take the second fraction, flip it upside down, and you multiply it out. That's as easy as it can be. Righto, guys, that is the 4 operations of rational numbers, and we'll go into each one into detail now. We'll be looking at some examples, and thereafter you'll be doing some yourself. Okay, let's look at some examples of the 4 operations, namely addition, subtraction, multiplication, and division. Let's have a look. The very first one, of course, is addition. And here we've got 2 small little fractions. Guys, I'm trying to keep the examples as simple as possible so that it's easier for you to understand. To add rational numbers, find a common denominator, and that's also, don't forget, must be the lowest common denominator for the fractions, and then add the numerators together. Right, in this case over here we can see 4 is going to be the lowest common denominator between the two, so We keep 4, 2 goes into 4 2 times 1 is 2, and then the quarter remains, so it's 2 plus 1, and that'll give us 3/4. Now this is already, it cannot go down into its simplest form. If you want to know how to make the simplest form, you just start dividing by 2. If you cannot divide by 2 anymore, then you must know you're in the simplest form. Let's go to multiplication. Once again, guys, we've got a simple, very simple problem here to solve. Multiply rational numbers, multiply the numerators together and the denominators together. So all you're going to be doing is to multiply them out. That's it. As easy as that. And we'll get 3 times 1 is 3, 4 times 2 is 8, and of course the answer is 3/8. 3 cannot go into 8 without a remainder, so it is in its simplest form already. Let's go and have a look at the next one. Subtraction. Now subtraction and addition is very similar to each other, only the symbol changes. To subtract rational numbers, find a common denominator for the fractions, and then subtract the numerators. Same, so exactly what you did for addition. 4 would be the lowest common denominator over here, so the 3 stays the same. 2 goes in there 2 times 1 is 2. Right, so it's 3 minus 1, and that gives us 1/4. And now, of course, that is in its simplest form already. We cannot go any smaller than that over there. Let's look at the last one, and that, of course, is going to be division. Once again, we've got quite a simple one to do. Now, to divide rational numbers, multiply the first fraction by the reciprocal of the second fraction. Now, that means what we're going to be doing here, and that is, as you'll see now, we have flipped the second fraction over, and now we're just going to multiply them out. That's all we're going to be doing, right? And there you can see we just multiplied them out, and of course just bring it down to a mixed number, and now we can see this fraction is still not in its simplest form, so let's take it into its simplest form. So the answer is 1.5. Righto, guys, that is some examples on how to do it, and if you're not sure, just go through them again, because now you're going to be doing some practice. Okay, next up we have got some practice, right, with the 4 operations: addition, subtraction, multiplication, and division. And here you can see they come up here already. Addition, we've got one, a very simple one over here. Addition number 2, a little bit more difficult, but also still simple. Guys, I'm trying to keep it simple so that you can just get practice on to see how to do it. Of course, you can have all 4 the operations in one problem, right? And there also the subtraction, a simple one, a little bit more difficult. In the next slide, we will be looking at the multiplication and the division. So I suggest at this stage you pause the video, do your solutions, and after that we'll move on to the next slide.
Hey, you must pause the video.
Okay, now let's move on, and let's go and have a look at the multiplication and division practice. Like just now, we've got them all together here at one time. Multiplication, also again, once a very simple one, a little bit more difficult one over here. Like I said, I'm trying to keep them all simple so you can just get the idea of how to do it. Division, also again, once the same thing over here, very simple, a little bit more difficult. Guys, it's just to get to see how to do it, a little bit of practice. Once again, I think pause the video, do your solutions, and then we'll check the solutions in the next slides.
Hey, you must pause the video.
Okay, we're making some nice progress over here. Now guys, let's go and look at our solutions of our practice problems, right? And let's do the first one over here. As you can see, sorry, I just did it by hand, because to try and type all this out over here in PowerPoint is quite difficult. Right, now as I said, we must find the common denominator. Now normally what I would do, I'll see if that figure can divide into that one over there. Now if I can divide that digit into this one over here, then I know I've got my lowest, this one here is going to be my lowest common denominator. So I saw that, so I said it goes in there 2 times, so I must multiply this whole fraction here by 2 to get it equal to that one over there. So it's exactly what I did. I've got 2/8 plus 1/4 times 2 over 2. So I'd multiply, because if I multiply the bottom, I must multiply the top 2. So that gives me 2/8 plus 2 over 8. So now I've got a common denominator over here. Put my common denominator down there, add my 2 numerators, and I get 4 over 8. But 4 over 8 is not the simplest form, because 4 can go into there 1 time and to there 2 times, which gives me 1/2. Great. That was the first one. Let's go look at the second one. This one here is a little bit more complicated because over here you must first bring this into a fraction and not a mixed number, which I did over there. 8 times 3, 24, plus 3, 27. Then I found the most common denominator over here. I just took 5 and multiplied it by 8 and I got 40. So I had to multiply both sides by the same thing over here. Multiply this by 8 to get it to 40. Multiply this one here by 5 to get it to 40. Do the both to top and bottom, and I get 16 over 40 plus 135 over 40. One common denominator, add the two numerators together, I get that over there. And then I can bring it back to a mixed number again. I get 3 with 31 over 40. Well, once again, with subtraction, it's exactly the same as what we did above over here. We find a common denominator. Yeah, I can't divide that in with no remainder, so I just multiply it. I get 10. So you must multiply this fraction here by 2 to bring 5 to 10, and this one here I must multiply by 5 to bring it to 10. There, I've done it. So in the end I've got my common denominator and my two numerators over here, and of course I subtract them from each other and I get my answer. Same over here. Once again, I've got a mixed number, so I must first bring it to a fraction. 4 times 2 is 8, plus 3 gives me 11. I can divide that into there, so the 4 remains, this fraction remains. I'll leave it unchanged. This one I can be multiplying top and bottom with 2. I get 11 over 4 minus 2 over 4. My common denominator, my numerator is 11 minus 2, gives me 9 over 4. Bring it back to a mixed number, 2 1/4. Guys, that is the solutions for those two over here.
Please check your solution and correct where needed.
Okay, let's go and have a look at the solutions for multiplication and division. Righto, let's go and have a look at the first one. This one is very easy because we're just multiplying them out. 1 times 1 is 1. 2 times 4 is 8, so it's 1/8. Simplest form, it can't go any simpler. This one here is a little bit more difficult. We must first bring this here to a fraction, change the mixed number into a fraction, and then we could just multiply them out. And of course we'll get, once we multiply them out, we bring it back to a mixed number again. We've got 6 over 8. That's not the simplest form. You can divide it by 2 and you get 3 over 4. Righto, let's go and look at the division. Once again, we just flip the last fraction and then we multiply it out and we get our answer. And of course, same one by this one, the division over here. We just flip the last fraction, multiply it out, and then we get our answer. Also again, once again guys, bring it back to its simplest form. Righto guys, please pause the video, check your solutions, and where you find a difference, please guys have a look at what has gone wrong and try and rectify it. And if need be, there are videos on how to multiply and divide fractions. Please watch them, make sure you understand it.
Please check your solution and correct where needed.
Okay, let's go and learn about some key takeaways that we have learned about this lesson over here. Right, the key takeaways and the next steps. The very first one, of course, is going to be rational numbers can be expressed as fractions that include whole numbers, fractions and terminating or repeating decimals. The second one, of course, that's going to be irrational numbers. We did do something about irrational numbers too. Cannot be expressed as fractions and have no repeating or non-terminating decimal representations. Righto. And then of course the last one, the 4 operations. Learn how to add, subtract, multiply and divide rational numbers with confidence. I'm quite sure that by now guys you have got enough confidence to be able to do it. You know all about rational numbers.